Hello everyone, myself Girish with SOLIDWORKS flow simulation tutorials. Okay, here we'll start with the external flow analysis. So in that we'll see how to deal with the SOLIDWORKS flow simulation from basics. So I'll take this one vehicle that is Range Rover car model into account, and you can activate the flow simulation from the add-in, and once you activate it you'll get these tools with respect to flow simulation. Okay, you can activate the wizard. From there you can define the study name. Okay, and once you define it you will be having the option to set your unit system. You can change the unit system to meter per second or kilometer per hour, and then the analysis type, external or internal, you just select the same, and accordingly you can select the gravity direction, and if you have the radiation or heat conduction into account or rotations are there into account, that you can here add it. Okay, right now I'll take it by default, no issues there. The fluid mediums, so there are enormous amount of fluids are available. You can simply choose which you are looking for. So here I'll consider the air as fluid medium. Flow type is laminar and turbulent because I'm considered high Mach number as well. Okay, and here you can define the velocity parameters. So along z direction I will define, so in the form of kilometer per hour I'll define 120 kilometers per hour. Okay, so the adiabatic wall we have selected into account, so there is no much viscous effect into the boundary walls. There is no boundary wall into account, so no need to worry. So this is the computational fluid domain. So you can customize it by using the arrow keys accordingly, or else you can use the manual method to edit the same. Okay, this time I'll simply drag it according to the manual arrow keys. So you can just switch the views as well to customize it like this. Okay, fine. So this looks good, and this domain is fine for me, so you can simply hide it for now. Okay, yep. So once you're done with this, again simply define the meshes. So there are advanced and automatic mesh to define there, and the goals you can set the total pressure and the velocities as well. So if you want to define the equation goals, that also we could do. That I'll let you know how to do it here. Okay, so here you could see the equation, the coefficient of drag, which is equal to 2 times of drag force divided by rho v square into s. Rho is the density velocity square into the frontal area we need to consider. Okay, lift, if you consider the same, coefficient of lift, which is equal to 2 times of lift divided by rho v square into frontal area. Okay, so the formula you could see there, it is CD, which is equal to 4 times of CG of force. So you'll get the goals over there. You will be having the different force along the directions like XYZ forces. So you can consider the along X direction with respect to the flow we can consider, and we can define the force. So automatically it will take that value into account, and then remaining steps, that is density, velocity, how much you have applied. So that is kilometers per hour, 120 kilometers per hour taken, so square of it you can consider, and the frontal area. To calculate the frontal area you need to take the evaluate option. From there you can select the front surfaces accordingly, and you'll get the surface area of the frontal area, that you need to add it there. Okay, once you define these properties, you can directly define the equation goal by using the goals option, and define the same equation, and that's all done. Okay, and then you'll get the coefficient of drag value to deal with the same. Next step is to deal with the mesh. So you can choose the mesh option. So you could see the automatic and manual method is there, so I'll go ahead with the automatic method. You can set the refinement level to 5, and then I'll simply run the analysis to just get the results. So it will take a while to just run the results. Okay, so it will go ahead with the iterative process to converge the results according to the residual values. Okay, so even you can activate the charts if you are looking for by using the chart options there. Yep, so Now you'll be having the results plot. You can use the same, so you can plot the mesh plot, cut plot, surface plots as well, and you can even add the float trajectories, x5 plots, and then you can get the goal plots as well. So if you have to find the equation goals, let's say here I need the cut plot. You can activate the same and you can choose the plane referral or reference plane which you're looking for, and accordingly you can select the which plot you're looking for, pressure plot or velocity plot. You can just select the same. So you have the show option to just visualize the same, or if you want to increase the intensity, or if you want to add the ISO lines or meshes into account, you can do the same. So right now I'll keep it as it is. Okay, you could see the velocity values. Okay, if you want to animate this, you can simply right click on the cut plot one, and you'll get the animation accordingly by using this option free. Okay, if you want to save this animation, you can use the animation option, and automatically you can just capture the screen to save the animations. Okay, so this is how the velocity distribution is happening. And if you want to deal with the isosurfaces, you can simply select the counters, and you can define the which type of appearance you're looking for. Let's say pressure or velocity, you can just simply select it. According to that, you'll get the isosurface. So how exactly the pressure is distributing and velocity is distributing, you'll get the same. So this will give the clear-cut idea about the how exactly the pressure or the velocity distribution is happening on the model. So according to that, you can just uh, optimize your safety model. Okay, so this is about isosurfaces. So according to the velocities, you can customize it. Remember that how exactly the velocities are happening, that you can customize. Let's say for 100 kilometers, if you want the isosurface, you can define the same. So this is the float trajectories, and here you can add the number of arrows. You can increase it or you can decrease it. Even you can decrease the chart. Okay, even the arrow markings, you can even add it to the pipes as well. So you can reduce the numbers, can customize the frontal area accordingly, and you'll get the uh, fluid flow on the vehicle model. Okay, so there are different options to deal with the same. So you can customize your entire uh, flow distributions according to the velocity, pressure, and you can increase the number of arrows or decrease the number of arrows. So it's all about your just requirement. You just define the same and you'll get the flow distribution. Okay, so this is how you need to carry out the simple external flow analysis. So we have seen how to just define the wizards, so how to set up the boundary conditions if you want to deal with. So here in external analysis, we have defined the velocity by using the wizard option only, and then we have gone through the goals and the setting up the meshes, and then we have seen how to customize the different plots like cut plots, iso plots, and even the, if you want, you can even add the surface plots. Okay, so that's all about this session. So we have covered most of the things in the basics. Yep, thank you all for supporting. Keep supporting. Stay tuned. Thank you.